and subtract when I plug in 0. So the answer is 8/3. And going back to our calculations, that was the exact with the limit of the Riemann sum. And now we want to look at this and check our answer for this, the previous one that we picked. So this will be the integral from 0 to 4. So this is the exact area. This is the exact area. 0 to 4 from x cubed plus 2x plus 1 dx. Good. Can anyone give us the antiderivative? And of course, from 0 to 4. Anyone would like to try?
X cubed, x to the 4th over 4 plus 2x squared over 2 plus x.
Excellent. Brilliant. Thank you. Of course, I'll simplify this and I'll plug in 4. There is no need to plug in 0 because when I subtract, all of them have 0 in them. So 4 to the 4th over 4 plus 16 and plus 4. So I'll simplify a 4. So I have 4 to the 3rd, which is 64, plus 16 and plus 4, which is 84. This is 20, 84. I think that's what we got. If not, I have to go back. Yes. 84. So this is what it's called, a definite integral. Why is it called definite? So first of all, a definite integral, number one, has limits of integration. And number two is always a number. Always. It has limits of integration, the lower limit and the upper limit. This is the area, base times height plus base times height plus base times height all the time. Same thing with the limit of the Riemann sum. This is the antiderivative of this function. It has to be evaluated first at the upper limit minus when it's evaluated at the lower limit. Again, there is no need to write plus c, because if I write plus c here when I have minus, at the end will be minus c. Plus c minus c will go away. Now, what I would like to do is, for the rest, I think we have like 10 minutes, I think. 10 minutes, right? Yes, 11. I would like us to choose definite integrals and determine them. I will choose the first, you will choose the second, or we can just make stuff up. Oh, never mind. So I will just choose from the old book. So I have it right here. It doesn't matter, they're all the same. So I just want to calculate definite integrals. There are properties that we have to look at definite integrals. Okay, so I would like to choose 26. And 26 has the integral from -5 to 5 from e dx. And you can say, what does this mean? No problem. This is a constant, right? It's e, the integral from -5 to 5 dx. So now we need to determine which function prime is 1, because there must be something in here. It cannot be 0. Which function prime is 1?
X, right?
That's it. Very good. Excellent. So I plug in 5, and I subtract when I plug in negative 5. So I plug in 5, and I subtract when I plug in negative 5. So this is 10e. Any questions? Any questions? Okay. Now, every time, two things that I want to mention here. Number one, FTC, fundamental theorem of calculus, requires f of x continuous on a comma b. So the integral from a to b from f of x dx is the antiderivative, the most general antiderivative from a to b, or f evaluated at b minus f evaluated at a, requires this function to be continuous. In other words, if I have the integral from -3 to 4 from 1 over x dx, notice that this function is not defined at which x value?
0.
Excellent. So 0 is 0 in this interval.
Yes.
I will write FTC not applicable. These are called, you have to wait till Calc 2. These are called improper integrals. FTC, fundamental theorem of calculus, part 2, not applicable. Okay, so careful. The other thing I was going to say, when the interval is symmetric, like the integral from -a to a from f of x dx, we always think in terms of only when the interval is symmetric, from -5 to 5, -10 to 10, symmetric, around 0, right? So we always think in terms of, or we want to verify if the function is odd or if the function is even. So this is a property that is important to remember. So I know that this is a function that is even, and this is x squared. So if I want to determine the area under the graph, right? So let's say between -a and a, the integral from -a to a from x squared dx can be replaced by twice this area. Do I have to? From 0 to a from f of x dx, or x squared. Since I wrote x squared, I want to continue with x squared dx. Do I have to do this? No. But if you always saw that the 0 as the lower limit will make my life easier, I only have to plug in, 0 is always easy to plug in, right? So then I'll determine as 2 x to the third over 3 from 0 to a, whatever that a is. And I don't need to plug in 0 because it's 0. So I get 2/3 a to the third, whatever a you want. Because the function is even. So I'll try to make my life easier in that way. Now, what about if a function is odd? And the interval, don't forget, the interval is symmetric and the function is odd. So here's the situation for an odd function. This is x cubed. We know it's odd. And I have a symmetric interval between negative a and a. So this is the area that we are interested in. What will equal the integral from negative a to a from x cubed dx? What do you think? Wild guess. Why? Because these two areas are equal, but this one is negative and this one is positive. So if the function is odd and the interval is symmetric, the answer is 0. If the function is even, but the interval is symmetric, then I can replace the integral with twice this integral, this area, because they are identical and both positive. They're above the x-axis. But if the function is odd, just write 0. For example, the integral from negative pi to pi from sine x dx, knowing that sine is odd and the interval is symmetric, I guarantee you the answer is 0. You don't have to calculate anything. The same with the integral from negative pi to pi, for example, from cosine x dx. But this is an even function, so this will be twice the integral from 0 to pi from cosine x dx. Any questions? Any questions? So at this point, I don't want you to start